Hey Scholars, it's Miss Marnon. So today we're going to be doing our markups lesson. So last class we did percent increase and decrease. So markups are just a specific kind of percent increase. It's just talking about money in stores. So stores will buy something at a wholesale price and then mark up the price so that they can make a profit. If you think about Costco, they call Costco a wholesaler. It's because they buy things really cheap and then you buy it kind of at wholesale price. So wholesale is always going to be our whole. So that's going to also be really helpful for us this year. But first, we have a review question. So the student population at Lincoln increased by 11%. This year, there were 555 students at Lincoln. How many students were at Lincoln last year? So pause the video, see if you can figure this out on your own. So this is one of those careful reading questions. So this is talking about this year at Lincoln. This is going to be our quantity. It's not our whole. Normally we do our whole and then we can increase it by 1%, but they're already giving us our quantity. So what we know is that our whole is going to be smaller if it increased. So the original year. But because they're giving us this quantity of after the increase, we need the percent after the increase. So if you wanted to think about it like a tape diagram or a double number line, when it was original in its whole, it was 100%. And that was some mystery number of students. Then it was increased 11%. So when you go up 11%, I don't know why my tablet keeps doing that. Now we are at 111%. So now we know that this is 555 students. So when we're going to do the percent with this quantity, we don't want to use 11%. We want to use 111%. So what we're going to do is we're going to set up quantity equals percent times whole, just like we've been doing with almost every percent problem. The quantity is the 555 students that we have now. Our percent, we're going to use the 111%. And our whole is our mystery number, X. So if you didn't get this set up, why don't you pause the video, see if you can solve it from this setup. Okay, if you are at school, you can do this math using 111%, using the percent button on the yellow calculators. But if we're at home or using Desmos, we can't do that. So let's just change this percent to a decimal. This is going to be 1.11 times X. And now we just go about solving it like we would any one-step equation. Because we have multiplication here, I want to do the opposite. So we're going to divide by 1.11. If I make a change on one side, I got to make the same change on the other side to keep it equal. So now this is going to 1 out, as I've been saying in class, because this is going to divide to be 1, and 1 times X is just X. And then we have 555 divided by 1.11. If you do this on your calculator, you should get 500 students. And that makes sense. We said our original was going to be less if it increased up to 555. And this is a new tablet, so I don't know why things keep popping up randomly, but I'll hopefully figure that out. Speaking of my tablet, Wacom tablet was originally $100. So it's telling me original. I already know that's the whole. The price was marked up by 1/4. So it just wants us to draw a tape diagram to represent the new price of the tablet. So this represents the $100 whole. So this whole thing is the $100 originally. Because my fraction is quarters, let's break this up into quarters. So now it was marked up. So really, we're going to add on an extra box of about the same size. So if you wanted to, you could split this 100 up into these 5 boxes, or into these 4 boxes. So 100 divided by 4, we're going to get $25 in each box. So now that it's marked up by a quarter, it's going to be marked up 25. So the new price would be $125. So that's just a preview. So that's going back to what we did with our fractions on our first few days of this unit, just to kind of get a feel for what it's going to be like when we start doing it with percents. And I'm going to just hit enter a few times so that I'm not running over my vocabulary. So markup, and I see it with a dash and I've seen it without a dash. It doesn't matter, I think, which way you spell it. We can ask Miss Torres or Miss Zahn, but I see it both ways all the time. So markup is just the amount of increase, and it's usually in dollars. So like when we were looking at our percent increase and decrease the other day, and we talked about how we could talk about how it went up, like Mounties, it went up 1 ring, or we could talk about how it went up 20%. So the markup would be like the ring or the dollars, usually, because markup's always dollars. The markup rate is the increase in price, and it's going to be a percent. So when we talk about the markup rate, that's going to be the percent. So like when we had the 5 rings and we increased by 1, going up the 1 would be the markup, and the markup rate would be like that 20%, except for now instead of rings, everything's going to be about dollars and money. So the important thing for us to remember here is the selling price is the sum, we know sum means add, of the original price and the markup. So that would again be like, instead of adding the 1 ring, it was like the 6 total for the increase. So to sort these into quantity equals percent times whole, quantity is going to be our markup, like the markup amount. Percent is going to be the markup rate. And your whole is going to be the original price. But there's another way we can do this, just like there was another way we could write out our percent increase and decrease. Let me just make this bigger and purple for us. So I'm going to actually insert another row below. The other way we do it is we could do the selling price. And instead of it being the markup rate, it's going to be the 100% plus the markup rate. Let's just do some spaces here so it looks better. So now this is like the 120% in the 6 rings. So now the selling price is the new price with the markup. So the percent is the 100 plus the markup rate, and the whole is still the original price. Something that's important to note about this is sometimes the original price is called the wholesale price. That's when we're talking about like stores that buy things to sell. They buy it at wholesale, so they buy it really, really cheap from who's ever making it, and then they mark that price up to sell it to us. So the nice thing about it being called wholesale is that it is our whole, and our quantity equals percent times whole formula. So let's look at some examples here. So we have our first exercise. A golf store purchases a set of clubs at a wholesale price of $250. Mr. Crisafulli learned that the clubs were marked up 200%. What is the retail price of the clubs? So this says wholesale price. I already know that's going to be our whole when we do quantity equals percent times whole. So there are 2 ways we can actually do this problem, and there's actually even more than that. We could do a tape diagram or a double number line, but I'm going to focus on doing the quantity equals percent times whole formulas for this. So it's important to note that this is the markup is 200%. So the new price isn't 200% of 250. It was 250. We're doing 200% more than that. So let's set up the first way. So this is solution path 1 that you could do. So we could do quantity equals percent times whole, where our quantity is going to be that markup. So we're going to figure out what that markup is. It's going to be our mystery number. We can use 200% as our rate, and our whole we're going to multiply by 250. So if you're using the yellow calculators at school, you can just multiply this with this percent sign right here. If you are using Desmos, you can do 200% of 250, or you can change this to a decimal and multiply by 250. But what's important to note is that we're going to end up getting 500. So that is the markup. That is not the selling price. The selling price, as we noted in our vocabulary up here, it's the sum of the original price and the markup. So the markup is 500, but we need to do the selling price plus the markup. So really, this selling price is going to be $750. So that's the first way you could do this problem. But we all know Miss Marnon is a lazy mathematician and always shows us the easy math way or the lazy math way. So I'm going to show you path 2 that you could do to solve this problem. This is the way I like to do these. So it's still quantity equals percent times whole. But now, because I want my quantity to be the selling price, so like just right here, like we made in this little chart, I'm going to use 100 plus the markup rate. So my quantity is still what we're trying to find, but this time we're going to go right to the selling price. The percent I'm going to use is 100 plus 200. I'm going to use 300%. Times our whole, it's still the original price, it's still 250. So now we can multiply this on our calculator, whether we use the in school or the Desmos, change this to a decimal if you need to, but you're still going to get $750, but now we just did it in one step. So I like the lazy math way, but if the first way makes the most sense to you, do it the first way. It doesn't matter. And this keeps moving down with, we're going to need this with the graph down below. So if that gets a little off kilter, just move it down. Okay, let's look at our next example. Kamanti bought new Jordans for the selling price of $160. So now this is the selling price. If we go back and we look, that's a quantity. That's not the whole. So I'm already going to label this quantity so I know. The wholesale price was marked up by 20%. What was the wholesale price? So for this one, instead of finding what the markup is, we want to figure out what the store actually bought it for before they sold it to Kamanti. So we're going to set up quantity equals percent times whole, just like we do for all of these problems. Our quantity we know is 160. That's the selling price. The percent though, we know the markup rate is 20, but if we look back here, when our quantity is the selling price, we have to kind of use the lazy math way where you do the 100 plus the markup rate. So 160 is really 120% of this whole. And that goes back to when we did the percent increase and that 6 went with that 120%. 160 is the 120%. It's not that 20% that it was marked up. So now this is one we can solve. This is just a one-step equation. If you're using the yellow calculators, you can just divide this out using the percent. But if you're not, you're gonna have to change 120% to a decimal, and that's just 1.2. Oh, and I kept it as a W. Oh, well, that's fine. Usually I like to change it to an X, but we can leave it as a W. So to solve this, we need to divide by 1.2 on both sides. And we get that W, or our wholesale price, is going to be equal to $133. Oops. And 33 cents. It's really 133.33333333, but we can't have an infinite number of pennies in money, so we're just going to round it to 2 places. Okay, this last exercise is a little bit of a longer one, but I think it's actually a really good one for us to look at and focus on. So write an equation to determine the selling price P of an item that is originally priced $D after a markup of 25%. So you can just go back and look at what we wrote here because it's talking about the selling price. So if the selling price is P, that's going to be our quantity. So we know P equals, the markup is 25, but when we're using the selling price, we're going to do 100 plus the markup rate. So it's really going to be 125% times the whole or the original price, which is just going to be D in this case. If we wanted to change this to a decimal, it would just be P equals 1.25 times D. So now it says create a table showing 5 possible pairs of solutions to the equations. So you're just going to pick some prices. So I'm going to do, let's see, what can I do? It's easy. Let's do 50. Let's do 100. 150, 200, and 250. So you can pick whatever prices you want. I'm just kind of going for nice round numbers. If you want to pick wacky numbers, you can. So these are all the price before markups. So this is going to be the D in this equation. So let's actually just highlight this. Let's do different colors. So these are all that part of the equation. Now we need to calculate the price after markup, which is this P. So all we need to do is multiply it by 1.25 and we'll be able to get these answers for this column. So why don't you pause the video and see what you get for our column for the price after markup. Okay, so let's just do this on Desmos. Let's do 50 times 1.25. I got 62.5 for the first one. You can do this over and over again, just replacing this number. So now if I want 100, we get 125. You can change it to 150 and get 187.5. 200, it's going to be 250. And then let's just check 250, 312.5. So those are all of our prices after the markup. So we can see it went up 25% for all of these. So my question for you guys to answer on your own, is it proportional? Is this a proportional table? So just kind of reviewing back to what we did in Unit 3. Is this table proportional? Why do you think so? Is this equation proportional? Why do you think so? So for now, we're going to make a graph of our data. So why don't you pause the video and see if you can plot these points on this graph. If you need help, I'll show you how to set it up. So if you need some help, let's start setting this up. So first we have a checklist over here. We need a title. So maybe you want some more room. I'm just going to say prices after 25% markup. So just fill that in. So we got a title. Now we need a scale. So it looks like we're counting by 50s here. We have a bunch of squares here, so I'm just going to make it where every 2 is 50. So that means every 4 is 100. And I'm actually only going to mark and write for the 100s now. So here's 200. And here is 300. So we could have done bigger numbers if we wanted to. We could even scale this out even further. But that is enough for us. And then we can see that we can do kind of a similar thing here. So we can do every 2 is 50. So here's 100. Here is 150. Here is 200. Here's 250. Here's 300. Here's 350. Here's 400. So now we've got a scale. We have to label our axes. So this is price before markup. And instead of X and Y, we have P and D. So this is D. This is going to be P. And this is going to be price after markup. So now we just have to plot some points on here. So we have 50 and then 62.5. So 50 and this is 75 is going to be kind of down here is that first point. 100, 125. So over 100 up, here's 125. 150, 175. So here's 150. It's going to be about here. 200, 250. That's going to be easy. That's going to be right on this line. And then 250, 300, 12.5. So if you're open in the app, you can actually get a straight line tool and draw it right through. I'm going to try my absolute best to just kind of freehand this with my tablet. It would help if this thing went away. Okay, maybe it's not going to go away. We're going to just do our best. We're going to continue all the way up and out. So we can see it's supposed to be a straight line. So again, is this proportional? Yes or no? Let me know what you think on your note page. And there is our lovely graph. So now we have, what does the point 0, 0 mean? What does the point 1, comma, k mean? So these are going back to that standard 7 RP2D that we've done on our data wall a couple of times. So the point 0, 0, so this is the price before markup, and then the price after markup. So if it cost $0 originally, after markup, it's still $0. So let's just type that in. So if it costs $0 before markup, it still costs $0. And that makes sense. If it didn't cost anything at all, when you mark it up, it's not going to change. But the 0.1K, or maybe 1R, however you've seen it, if we had something that cost $1 after markup, if you multiply by 1.25, it's going to be $1.25. So each dollar gets marked up to $1.25. Or you could say that an item costing $1 gets marked up to $2 or $1.25. Lots of different ways we could interpret that, as long as we know that the $1 means the price before and the $1.25 is the price after. So when you are all done with these notes, we have some practice in class. You're only going to need to pick 2. And I am going to let you know that this third one is a little bit harder. I like to include a challenge one whenever I can. So this one might have some extra steps, or you might need some careful reading, but number 3 is a challenge. So pick 2 of these. If you want to just stick to easy ones, do 1 and 2. If you want a challenge, try number 3. Then you have your exit ticket. So you're going to have to figure out which of these equations you want to use for this story. If you need to, look back at this table that we filled out for quantity equals percent times whole to see which of those numbers fit where. Solve for X, and then what does it represent? When you're all done with your practice and your exit ticket, make sure you're going to Delta Math and complete practice 5.